All right, so last time we started working with differential equations, we looked at two different things. We looked at verifying that a solution works, and we looked at taking a general solution that works and finding the particular solution through a specific point. Does that sound like pretty much what we did, if you remember? Awesome, good. All right, so today we're going to work on the last two parts of this section, and you'll notice this one actually says that we're going to use integration, so we're going to integrate this time, and we're going to find the general solution. So when we're taking a look at this, we're going to use integration methods we've seen before, but what you want to keep in mind in Chapter 6 is in Chapter 6 you haven't encountered Chapter 8. I know it sounds sort of obvious, but you realize that, right? So all those techniques that you saw in Chapter 8 won't show up in here. And that's a good thing. From your perspective, it should be, because that means you don't have to look at this and think, don't use integration by parts, because the answer has to be no, because this is Chapter 6, and Chapter 8 is when we learned integration by parts. Are you tracking with me? Okay. So the things that we knew at this point, having completed Chapter 5, was that we knew integration with substitution, right? You knew that from Calc 1. You knew a little bit of algebra techniques, so maybe long division or factoring, and not factoring and doing partial fractions, but factoring to simplify each piece over something or something like that. Okay, so you knew some algebra techniques, and that's just about it. We didn't really have all these advanced techniques, which means the integration you're going to see in this chapter is going to be really easy compared to what we've been doing anyway, okay? So over here, the first thing you're going to look at when you see this, or you're going to notice when you see this, is that you've got dy dx on one side and you've got the values on the other, okay? So the first thing I'm going to do is I'm going to multiply that dx to the other side. dy equals x cosine x squared dx. And once I have it in that form, I can actually put integration symbols in and they make sense. Right? So on the left-hand side, what is the integral of dy? Y. Now very technically it's y plus c, but we're going to put a plus c on one side or the other. We don't need it on both sides, so I'm going to tend to put it on the right-hand side just by default. Okay. Now, what method do I need to use to do integration on the right-hand side? U substitution, right? So what would you like to let u be, Cameron? X squared sounds excellent. And then du would be 2x, right. 2x dx, thank you. That's actually much more specific. And then we'll divide by 2. So when I'm rewriting this piece, I've got a 1/2 times the integral of what? Good, cosine of u du. Now then, what is the integral of cosine of u?
Sine u.
All right, so I've got 1/2 sine of u plus c. There. And then the last thing that we would need to do is what? Substitute back. So 1/2 sine of x squared plus c. And that's my general solution. Simple enough? Okay, let's try another one. Same directions. My value here is not trig. I used a trig sample number 1 or part A or whatever. On this one I've got an exponential example. Process starts the same though. I multiply the dx to the other side. So y equals 5 e to the negative x over 2 dx. Now what? What do I do next? Yeah, I'm going to put my integral symbols in. On the left-hand side, integral of dy is y. On the right-hand side, this actually has a u substitution in it as well, yeah? So what's my u? The exponent, negative x over 2. And I know that some of you can jump past this step and can figure out what to do next, but just in case, because this one's a little different since it's not actually multiplied by 2, it's divided by 2, so I just want to make sure you're aware that it looks a little different. What is the derivative here of negative x over 2? Negative 1/2 dx, right? So I actually either want to divide the negative 1/2 to the other side or what? It's going to look weird if I write divided by negative 1/2 y.
Because you have to switch the
Why does that look weird?
times prime and multiply by.
Yeah, so this looks weird because it's a fraction with a fraction denominator, correct? So instead of dividing by negative 1/2, what could I do?
Times by negative.
Right, I'm going to multiply by negative 2. So my integration over here actually has the 5 that's already there and negative 2. So I have negative 10 times the integral of e to the u du. Okay, so the left-hand side we already said is y equals. What's the antiderivative of negative 10 integral of, or I should say, what is negative 10 integral of e to the u du?
Negative 10 e to the u plus 2.
Right. And of course, my last step is to substitute back, right? It's all good?